Hello my dear students and welcome to the chemistry classes. So students, in the previous session we have solved the questions based on the colloids of level 1 and level 2 we have solved. In today's session we will solve the questions which have come in the Karnataka CET. Okay, along with that we will solve some of the questions from the NCERT examples. First I would like to take the questions which have appeared in the Karnataka CET. So let's get started. Okay, the first question, what it is saying? The first question, gold sol is an electronegative sol. The amount of electrolyte required to coagulate a certain amount of gold sol is minimum in case of. See, here they are saying, here they are asking you what gold sol is there, which is electronegative, and they are asking you the amount of electrolyte required. Whenever say they will ask you the amount of electrolyte, it means what? One thing should come into your mind. There are two things. One is coagulating power. One is coagulating power, and another one is flocculation value. Okay, these two are inversely proportional. First thing, you understand what is meant by coagulating power. Coagulating power means the oxidation state of the cation or the anion. Okay, for example, now if I take positively charged, see, sodium is having only one oxidation state, that is +1, then will come magnesium +2, then aluminium is having +3. Okay, now coagulating power means what I just said, higher oxidation state. So between these three ions, okay, which is having higher coagulating power, aluminium is having higher coagulating power. It means what? Its flocculation value will be minimum. Okay, flocculation value will be minimum. Now what is mean by flocculation value? The amount of electrolyte required to cause the coagulation or to cause the precipitation. Okay, higher the oxidation state of the ion, minimum will be the flocculation value. Okay, now they will confuse you what? They will ask you, they will give you certain colloidal sol and they will ask you the question in two ways. The minimum amount required or maximum amount of electrolyte required. When they say you minimum amount of electrolyte, then it should be flocculation value. You have to choose. When they say minimum flocculation value means oxidation should be higher state. When they ask you maximum flocculation value, then the oxidation state has to be lower. Okay, in the same manner they will ask you for the coagulation power. They will ask you minimum coagulating power or maximum coagulating power. Okay, when they will say maximum coagulating power means higher oxidation state, minimum coagulating power means this one, minimum oxidation state, because these two are inversely proportional. You have to remember this. Again I will repeat you, minimum flocculation value means higher oxidation state, maximum flocculation value means minimum oxidation state. Opposite to this will be maximum coagulation power means maximum coagulation power means maximum oxidation state, minimum coagulating power means minimum oxidation state. Now as per this question, see, gold sol is an electrolyte, electronegative sol. The amount of electrolyte required to coagulate a certain amount of gold sol is minimum. Now they are asking you what? Minimum. They are asking means minimum flocculation value should be there. So among these, see, already they have mentioned gold sol is negatively charged. So among all these are positively charged. So just check, aluminium is having +3 oxidation state. Aluminium is having +3. Here 2 sodiums are there. So it will be 2 Na plus, means Na plus is having 2 Na2. Okay, +2 oxidations you can consider. Calcium is there, calcium is having +2, again sodium only 1. Okay, so which is having higher oxidation state, amount of electrolyte required will be minimum. Now they are asking you minimum amount of electrolyte means what is your answer? It should be aluminium chloride. Okay, so you should answer the questions in this way. Okay, I hope you are understanding. Coagulating power is inversely proportional to the flocculation value. Okay, now we will move on to the next question. Second, in case of small cuts, bleeding is stopped by applying potash alum. Here alum acts as, or here alum is what? Okay. See, whenever bleeding, whenever small cut will happen on our skin, when the blood is coming out, after some time the bleeding will stop. Why? We know that the blood get thickens at that part. When I say the blood is getting thickened, means what? The blood cells are growing, or some precipitation is happening. Okay, you have seen the precipitation, means the blood cells are getting precipitated. Okay, the blood cells are getting precipitated. So when the blood will precipitate, see, bleeding is stopped by applying potash alum. Potash alum is a medicine, means when you apply potash alum, quickly the blood will convert into precipitate. So what is that process is known as, or the potash alum acts as? The potash alum acts as what? No, it is not acting as a germicide. Coagulating agent. Coagulating agent means precipitation agent. Potash alum makes the blood to precipitate quickly. These two are not applicable. Okay, so the answer, you should look into the questions like this. Okay. Third question, the simplest way to check whether a system is colloidal. Okay, see, let's look into the option. Okay, the simplest way to check the given solution is colloidal or not. What are the options that they have given? I'll explain. They have given the first thing is electrodialysis. We know that electrodialysis is a process for the purification of colloid. It is purification of colloid. So it is not a method to check the given solution is a colloid or no. No, it is not the answer. Then finding out the particle size. Again, to find the particle size, you have to do the research, isn't it? First you have to filtrate. After filtering, when the colloidal particles are coming, then you have to measure the size of those colloidal particles. So it will take a lot of time. Okay, so it's not that easy way. So this is not the answer. Then third one is saying Tyndall effect. What do you mean by Tyndall effect? See, Tyndall effect means, okay, I'll take a colloidal solution, or I will take the given solution and I will pass the light. Suppose this is my light source and I'll pass the light through this. Okay, and if the path becomes visible, if the path of the light becomes visible, then we will say the given solution is colloidal. Why we will say the given solution is colloidal? Because we know that colloidal particles will scatter the light, and when the light gets scattered, the path of the light becomes visible. This path of the light is called as Tyndall cone. So very easily we can do, take the given solution and pass a light, and if the in a dark room, okay, in a dark room you have to perform the experiment. Okay, so if the path of the light becomes visible, then clearly we can say this is a colloidal solution. Okay, so this is the easiest way. So answer will be what? Tyndall effect. Okay, Brownian motion. See, Brownian motion means the zigzag motion of the colloidal particle. Now to see the Brownian motion or the Brownian movement, again you have to require a high power telescope. So easily you can do the Tyndall experiment. So this is the easy way. So the answer is Tyndall effect. Next one. Okay, now the concentration of electrolyte required to coagulate a given amount of arsenious sulfide sol is minimum in case, again they have asked you flocculation value. Again what they have asked you the flocculation value. Okay, minimum amount of electrolyte means flocculation value only, because flocculation value will tell, now remember this, flocculation value will tell you amount of electrolyte required. Okay, what is flocculation value is telling you? Amount of electrolyte required. Okay, so now they are asking you arsenious sulfide, this is a negatively charged sol. Okay, so negatively charged sol is there. So magnesium nitrate. Okay, magnesium means what charge will come? +2 charge will come. Potassium nitrate, again K2NO3 it will be. Okay, K2NO3 or K potassium nitrate. Yes, this magnesium nitrate means MgNO3 twice. Then potassium sulfate, K2SO4. Now go on calculating. This is +1, this is +2, this is again +2 here. Usually potassium is +1, but there are 2 potassiums are there. Okay, so +2. Now aluminium nitrate, AlNO3 thrice, means aluminium is having +3. So minimum amount required means higher should be the oxidation state of the cation. Now I will consider cation. Why? Because arsenious sulfide, this is what? Negative sol. This is negative sol, all these are positive sol. So the cation which is having higher oxidation state will be required in minimum amount. Okay, so now then your answer will be what? 4th one. What is that? Aluminium nitrate. This is your answer. Okay, yes. Then moving, yeah. The next question is saying that pick out the statements which is not relevant in the discussion of the colloids. Okay. The first one, sodium aluminum silicate is used in the softening of the hard water. Second one, potash alum is used in shaving rounds and as a styptic in medicines. Third one, artificial rain is caused by throwing electrified sand on the clouds from an aeroplane. Okay, let me explain one by one. Now see, this one is not relevant only because colloids are not used in softening of water. Actually, colloids will be used for the precipitation of the water, okay, or cleaning of the water, not the softening of the water. Okay, so this is not required. See, potash alum is used in the shaving rounds, means whenever during the shaving any cuts are there, so whenever bleeding happens, so during that time potash alum is used. So again potash alum, just now we had seen potash alum is going to act as coagulating agent. Therefore, this is relevant to the colloids. Next, artificial rain is caused by throwing the electrified sand on the clouds from the aeroplane. Now, you already know the artificial rain. I'll tell you what happens. In artificial rain is, see, whenever the clouds are there, clouds will be containing what? Water content or water vapors. Okay, so when we throw the electrified sand on them, okay, then they will get precipitation, means water vapor will convert into condensation, means water vapors will be converted into water and rain will happen. Okay, again this is relevant to the colloids. Then last one, deltas are formed at the place where the rivers pours its water into the sea. Okay, delta region means, see, when a sea meets a river, okay, there, you know, in sea lot of electrolytes will be there, means salt is nothing but your electrolyte. We know that whenever maximum amount of electrolyte will be there, what will happen? Okay, precipitation will happen. So delta region means the deltas or delta region means what? The place where river and the sea meet. Okay, so in sea water lot of electrolyte will be there, and any colloidal particles are there in the river water, then they will get precipitated. Okay, so this is also relevant to the colloids only. So the first option is not relevant to the colloids. So your answer is what? This is your answer, means this is irrelevant. Okay, then next question. Okay, so the next question is saying, see, the diameter of the colloidal particles ranges from, means they are asking you what is the range of the colloidal particles, but what is important, they have given you the unit in meters. See students, always have during the theory classes also have mentioned about, see, they will ask you questions based on, I mean in board examination also the tricky questions will be coming on the size of the colloidal particle, remember that. So I'll again once again write for you people. See, when it comes to in meters, it is from 10 to the power minus 9 meters to 10 to the power minus 6 meters, or one is 1 micrometers to 1 micron, then 1 nanometer to 1000 nanometers, then 10 angstroms to 10,000 angstroms. Okay, or 10 to the power 4 you can write, 10 to the power 4 angstroms you can write. Then again 1000 picometers or 10 to the power 3 picometers to the 10 to the power 6 means 10 lakhs, 10 to the power 6 picometers. This you have to remember, especially this one. Okay, and Usually they have asked these two. So again, I mean, it's compulsory that you must remember. Okay, you must remember. So among these, now meters they have given. So whichever among the given options, whichever is resembling this, that will be our answer. So first one is saying 10 to the power minus 6 to 10 to the power minus. Okay, this will be our answer then. Then that is our answer. First one is the direct answer they have given. Yes, this is the answer. First one. Okay. Then moving on. Yes. Potash alum, again, alum is a water purifier because it, okay, coagulates the impurities, softens the hard water. No, it coagulates means, see, in the old days they used to bring the potash alum. You might have seen, I have seen at least. See, whenever we used to go to the our villages, or whenever we used to go to our native places during our childhood, our uncles and all, they used to bring this potash alum and they used to throw in the well. ಭಾಮಿ ಒಳಗಡೆ ಅದು ಪೌಡರ್ ಹಾಕ್ತಿದ್ರು. ಯಾಕೆ ಹಾಕ್ತಿದ್ರು ಅಂತಂದರೆ, ನಾವು ಸ್ವಿಮ್ಮಿಂಗ್ ಕಲಿಬೇಕಾದ ಹೋದಾಗ ಅಲ್ಲಿ ವಾಟರ್ ಸ್ವಲ್ಪ ಗಲೀಜಿತ್ತು ಅಂತಂದರೆ ದೇ ಇಸ್ ಟು ಆ್ಯಡ್ ದಿಸ್ ಪೊಟ್ಯಾಶ್ ಅಲಮ್. ಸೊ ಆ ಪೊಟ್ಯಾಶ್ ಅಲಮ್ ಹಾಕೋದ್ರಿಂದ ಏನಾಗ್ತದೆ ಅಂತಂದರೆ, ಅಲ್ಲೇನು ಇಂಪ್ಯೂರಿಟೀಸ್ ಇರ್ತಾವಲ್ಲ ಅದನ್ನು ಅದೇನು ಮಾಡ್ತದೆ, ಪ್ರಿಸಿಪೇಟೆಡ್ ಮಾಡಿ ಕೆಳಗಡೆ ಸೆಟಲ್ ಆಗೋಂಗೆ ಮಾಡ್ತದೆ. ದೆನ್ ವಿ ಕ್ಯಾನ್ ಗೆಟ್ ದ ಕ್ಲಿಯರ್ ವಾಟರ್. Okay, so potash alum is a water purifier because it precipitates the impurities. Precipitate andru onde, coagulates andru onde. Okay, so first answer is the answer. Okay, potash alum does not give the taste, it destroys the pathogenic bacteria. No, first is the answer. Okay, next, moving on to the next question. Then an emulsifier is a substance which, see, what is an emulsifier? Emulsifier is an agent which is present in an emulsion which stabilizes dispersed phase and dispersion medium. Okay, it is going to stabilize the dispersed phase and dispersion medium. So among this, what is the answer? First one, stabilizes the emulsion. But look into the other options. Homogenesis the emulsion. No, it is not homogenesis. Then coagulates, no. Emulsifying agent does not precipitate the emulsion. Then fourth one is saying accelerates the dispersion of the liquid in liquid. No, first one is it stabilizes the emulsion. First one. Okay, you should remember these, you know, direct emulsifying agent and all direct questions are there. Okay, next one, which of the electrolyte will have a maximum flocculation value for the ferric hydroxide? Now ferric hydroxide, it is also negatively charged. It is negatively charged colloid, ferric hydroxide, remember that. Okay, it is negatively charged. Here all positive given means it is negatively charged only. Okay, now they are asking you what? See, maximum flocculation value. When they say maximum flocculation value, means the oxidation state of the cation will be low. So among this, which has the lowest oxidation state? Here sodium has +1, here 2 sodiums are there, so +2. Here ammonium phosphate, so ammonium is having 3 ammoniums are there, so +3. Then potassium +2, which is having the lower oxidation state. Yes, this is having the lower oxidation state, means sodium chloride has maximum flocculation value or minimum coagulating power. So maximum they have asked, isn't it? Yeah, maximum means sodium chloride has maximum flocculation value. Okay, then moving on to the next question. Okay, when a sulphur salt is evaporated, sulphur is obtained on mixing with water. Sulphur salt okay, sulphur is not formed. Okay, see, when a sulphur salt is evaporated, sulphur is obtained on mixing with water. Sulphur salt is not formed. The salt is means, see, here they are asking you about the nature of the colloidal salt. See, it's just like whether it is a given colloidal salt is reversible or irreversible. See, remember this also, irreversible, and another one is reversible. What do you mean by reversible? Just like when your water, when you heat it continuously, water gets evaporated, you will get the salt. Okay, Again, when you add water to the salt, again salt dissolves into the water, means that is reversible. Okay, then the colloidal solutions, I will say reversible. See what will happen again. I'll take a colloidal solution. Again I'll heat it. What will happen? The dispersion medium will evaporate, and what is I am left with? I am left with the dispersed phase. When I again add the dispersion medium to the dispersed phase, and if I get back the colloidal salt, then I will call it as reversible. This is possible. This is possible only when the dispersed phase and the dispersion medium are having affection towards one another. If they are not affection, if they are not having affection, then once the dispersed phase and dispersion medium are separated, and again after adding the dispersion medium to the dispersed phase under normal conditions, if you are not getting the colloidal particles back, then it means what? They are not having affection. Here the same thing is happening, means sulfur salt is evaporated, I will get the sulfur, and once again when I am adding water, I am not getting the sulfur colloidal salt. It means what? It is irreversible, means dispersed phase and dispersion medium are not having affinity. Then what kind of an colloidal salt it will be? Either, I mean, here I have mentioned about water, means it will be hydrophobic. Why hydrophobic? Means water and sulfur are not having any affinity, therefore we are not getting back the sulfur salt. Once again after evaporation of water, when I add water, I am not getting the sulfur salt, therefore the answer will be hydrophobic. Lyophilic means these are reversible. Remember, lyophilic is reversible. Okay, lyophobic will be irreversible. Okay, so okay, lyophilic no, reversible no, hydrophobic yes, not the hydrophilic. Hydrophilic means same like lyophilic only. Okay, so the answer will be hydrophobic. Remember. The next one is the color of the sky is due to, see, the color of the sky or the color of the sea or even the rivers is because of what? See, even in sky we will observe, even in the sky, see, small dust particles are there. Those dust particles size resembles to that of the colloidal particles, and when the sunlight falls on those dust particles, what will happen? Colloidal particles will scatter the ray of light. Same thing, those atmospheric dust particles will scatter the light, and the wavelength of the scattered light that we see is blue in color. That's why the sky appears blue. Okay, so what is the option you have to choose in this? Obviously the first one is wrong. Why the first one is wrong? Because they are saying absorption of light. Light cannot be absorbed by the dust particles, they are scattering it, that you have to look. Then transmission of light, no, they are not getting transmitted. Then wavelength of the scattered light, yes, this is our answer, not all of these. Okay, if the light is absorbed, then dark color we should see. Okay, so yes, answer will be third, wavelength of the scattered light. Then next, which one of the following does not involve a coagulation or precipitation? Okay, formation of delta region, yes, just now only I have explained you, when a re meets the place where the river meets the sea is called as delta region. So their delta region, again coagulation will happen. So this is the answer. Okay, but other also, let's see the reasoning. What is meant by peptization? Peptization is a process. Okay, peptization is a process during which a precipitate will be converted into freshly prepared precipitate will be converted into colloidal particles. So this is not. Then treatment of drinking water by potash alum. Then what will happen? Again precipitation will happen. Okay. Which one of the is not involved in coagulation? This is not involved in coagulation because this is opposite to coagulation. Okay, then the answer will be peptization. Peptization is not involved with the precipitation. In fact, peptization is involved in converting the precipitation into colloidal particles. So peptization is the answer, because here also precipitation will be formed, PPT formed. In third option, here also PPT is formed. Clotting of blood means again here also precipitate is formed. So only in peptization only precipitate is not formed. So peptization is the answer. Moving on to the next question. Which one of the following is an example for homogeneous catalysis? So okay, this is catalysis which we have already discussed. Okay, then again one question is there which is similar to this, that is, which one of the following does not involve coagulation? Again, see, clotting of the blood, it again involves coagulation. Formation of delta region, it again involves the precipitation. Treatment of drinking water by potash alum, this also requires reverse of that only question. The peptidization, answer straight away. Okay, next, dialysis can be used to separate what? Okay, what is dialysis? First understand what is meant by purification of colloids. Purification of colloid means we have to separate the extra amount of electrolyte present in the colloidal salt. Okay, so separation of what? Extra electrolyte, okay, from the dispersed phase or colloidal particles. Let us look into the options. Here glucose and fructose, no. Glucose and fructose, dialysis is not a process wherein we will be separating glucose and fructose, no. Second one, protein and starch, no. Third one, glucose and protein, no. All of these are what? Solutions only, true solution particles. And fourth one, yes, now see, glucose and NaCl. Now NaCl is electrolyte. Just now I discussed you, it is a process of wherein we will be separating dispersed phase and electrolyte. So in this, glucose is separated from the NaCl. So your answer is fourth one. Okay, the next question is, see, 28th question, it is saying that all colloidal dispersions have, means in a colloidal solution, what is the dispersion osmotic pressure of the, yes, osmotic pressure of the dispersion medium is just like. So see, in osmotic pressure, as we know, when you add a solute to the solvent, what will happen? Vapor pressure is reduced. Okay, therefore osmotic pressure will be lowered. So which is that? Okay, second one, just like that, lower osmotic pressure. See, it cannot have high osmotic pressure. Okay, then definitely some all the liquids will be, I mean, when they are separated, dispersion medium and the dispersed phase, when they have separated, definitely there will be, I mean, mixed, definitely there has to be some pressure or osmotic pressure has to be there. There cannot be no osmotic pressure at all. Okay, then very high does not matter. So it is the low osmotic pressure. Moving on to the next question. Okay, question number 29. It is saying that silver iodide is used for producing artificial rain because AgI. Okay. Okay, then, okay, silver iodide is used for producing artificial rain because of what? See, one, it is easy to spray at a higher altitude, it is easy to synthesize, has a crystal structure similar to ice, then insoluble in water. No, I think it is the answer, has the same crystal structure similar to ice. It is having the same crystal structure that of ice. Okay. Okay, there. Now next question is, the stability of lyophobic colloid is due to, see, lyophilic, first thing, lyophilic and lyophobic. Lyophilic and lyophobic. Okay. Now lyophilic is more stable, as we know, lyophilic is more stable and lyophobic is less stable. First, let us understand why lyophilic is more stable. Because dispersed phase and dispersion medium have affinity. Have affinity means both are having affinity towards each other. Here it is opposite. Both are having hatred nature towards one another. But still lyophobic colloids are there. Why they are? Because here the dispersed phase has some charge on it, either positive charge or negative charge. Due to the presence of the charge, each of the colloidal particle can stay away from each other, otherwise they'll get coagulated, isn't it? So this is not there, means both the dispersed phase and dispersion medium are not having affinity, but due to the presence of charge on the dispersed phase, they are little bit stable. Okay, then let us look into the options first. First is adsorption of covalent molecules on the colloids. No. Then actually adsorption of ion should be happening. Then it would have been the correct answer. But they have said covalent molecules, which is not. Then the second one, the size of the particles. No, size does not affect the stability. Then the third one, the charge. Yes, just now what we have discussed, the charge on the particles. Yes, this is the answer. Not the Tyndall effect. Tyndall effect is a consequence of the colloidal particles. Then moving on to the next. Okay. Which of the following cation will have the minimum flocculation value for the arsenic sulfide? I think we have discussed about it. So answer is straight away I will go. That is sodium. First one. Okay. Next question. Okay, next question is saying the electrolyte having a maximum flocculation value. Now they are having what? Maximum flocculation value means oxidation state has to be minimum. Which among this is having minimum oxidation state? Here see, +2, as 2 sodiums are there, +2 here, +1 here, +3, and here again +2. Okay, so minimum means this is, so this will be having maximum flocculation value. So the answer will be second. The next question is, which of the following colloids cannot be easily coagulated? See, there are two types of colloids. One is lyophilic and lyophobic. Okay, so as we know, in lyophilic, dispersed phase and dispersion medium have affinity, whereas here hatred nature is there. So when hatred nature is there, here when affinity is there, now it is very difficult as to separate the dispersed phase and dispersion medium. Precipitation means what? You have to separate the dispersed phase particles. When dispersed phase particles are separated, one dispersed phase particle, another dispersed phase particle, they will combine and they will get precipitated. So in case of lyophilic colloids, it is not that easy to separate the dispersed medium and dispersion medium. As here in lyophobic colloids, both are having not a good affinity or hatred nature will be there. So we can separate easily the dispersed phase and dispersion medium. Then easily precipitation will occur. So here what are the options? First one, macromolecular colloids. Second one, it is a type of colloid, okay, lyophobic colloids and irreversible colloids. And fourth one, multimolecular. Now first option, second option are irrelevant. Then comes lyophobic colloids. Yes, just now we have discussed about this, isn't it? Lyophobic colloids. In lyophobic colloids, okay, lyophobic colloids can be easily precipitated. Why? Because in lyophobic colloids, dispersed phase and dispersion medium are not having good affinity with one another. So this goes that. Next question. Okay, so the next question is saying, okay, sulfur salt contains, okay, see, sulfur is just like, this question appears sometimes. See, if you take the metals like what? Gold, silver, platinum. Okay, these are all what? These are small gold particles. They will get collected. And they will become colloidal particles. So they are the aggregates. They are the aggregates or the union, I can say, union of the small gold metal particles. Okay, sulfur is also same. Sulfur exists in the form of S8. Okay, so 8 sulfur atoms have combined and then they have become the sulfur colloidal particles. Okay, then sulfur salt contains what? Larger aggregates of sulfur molecules, discrete sulfur atoms, water dispersed in solid sulfur. No, these two are not. Discrete means small, not the larger. This also not. It cannot be larger. So it is the atoms, not the molecules. It is the discrete sulfur atoms, not the molecules. Okay. Then next. The process which is responsible for the formation of delta at a place where rivers meet the sea is, means when river meets sea is called as delta region. In the delta region, what will happen? We have discussed it just in the session. We have discussed it 2-3 times. It is coagulation straight away. Okay. Emulsification, no, not the emulsification. Colloid formation, no. Peptization, no. Okay, why peptization is not the answer? Peptization is conversion of a precipitate into a colloidal particle. Then colloidal particles are not forming there, precipitate is forming there, emulsification is also not happening. Okay, then okay, next question is the critical micelle concentration for a soap is 1.5 into 10 to the power minus 4 moles per liter. Micelles formation is possible only when the concentration of a soap solution in moles per liter is. Now we know that CMC, critical micellization concentration, okay, above this if the concentration goes, then only colloids will be formed. We call that as associated colloids. Associated colloids, or we call them as micelles. We know that micelles are formed when the concentration is higher than CMC. Concentration is higher than CMC. Micelles are formed when the concentration is higher than the CMC. Okay, then now the concentration, what they are saying, critical CMC they have saying is how much? 1.5 into 10 to the power minus 4. So above this value you have to search. Then above this value is among this, see 10 to the power minus 5, no, 1.1 into 10 to the power minus 1. Okay, no, again it is lower. This is the answer, 2 into 10 to the power minus 3, higher value. Okay, so the answer is 2 into 10 to the power minus 5. Last is again saying 10 to the power minus 5, so not possible. So it has to be 10 to the power minus 4. Okay, yes. So these are the questions which have been asked in CET, Karnataka CET. Okay, now we will discuss about the NCERT example problems.